Okay.
Hi, this is Sammy Azad, fourth-year philosophy major, and
I am Emily Christner, a second-year biology major.
And we're here to present you with a solution in number 12 on page 82 from chapter 9, section 2 in the chemistry problems workbook. Let's set up the problem first. The problem asks how many moles of helium gas are there in a helium balloon that has a volume of 4 liters. Here's our helium balloon, 4-liter volume, and we got a temperature of 25 degrees Celsius going on, and we got a pressure of 1 atm. So, we want to find out how many moles of helium gas we have in this balloon. We know the volume, but we need the moles. So first thing we do, we want to sort of estimate, have a guess of what's going to come out. One thing we can use is that at STP, 1 mole of gas ideally is equal to 22.4 liters. Regardless of its lack of applicability, we can use it to potentially make an estimate or range of the answer in moles. Since we're at 25 degrees Celsius above STP, we can guess that our gas is more expanded than a gas at STP due to the temperature difference, and assume it takes up more space. But we can use it as a good ballpark to check our final answer against. So in that case, if we have X moles right here, and that X moles is equivalent to our proportion of volume where we have 4 liters, we can use the 1 mole is equal to 22.4 liters and put that on the bottom of our proportion. In other words, put 1 mole under X, which would be the actual number of moles we have, and we'd put 22.4 liters under the 4 liters we have. This creates a mole-to-mole, volume-to-volume proportion that we can use to estimate our final answer. So if we do the calculation, we're going to have about 1/6 on this side, and we'll have X on this side. So we can see that X is going to be about 1/6 moles.
To solve this problem, we'll use PV equals nRT, which is our ideal gas law, where P is pressure, V is volume, N is number of moles, R is a given constant, and T is temperature. So let's write out what we already have. So pressure from the problem above is 1 atm. Volume is 4 liters, which is up above here. R is 0.082, which is a given constant we can look up. And T is going to be 298, which is in Kelvin. So when we calculate, since we're in Celsius, we'll add 273 degrees, which will equal 298. So let's plug this in back into the equation. So 1 is for pressure, 4 for volume. We are solving for N. R is 0.082, and temperature is 298. And then we isolate N, which would be 4, because 4 times 1 is 4, and then over 0.082 times 298, which would equal 0.167, which is close to our estimation up here of 1/6. Thank you for listening.